Okay, hello. My name's Kevin Braun, and today I'm going to be modeling a singular pile that is embedded within a soil domain. When looking at the geometric attributes of this model, the diameter of the pile is going to be 400 millimeters, where the total length of the pile is 7 meters, um, where 6 meters of the pile is embedded within the soil, which means that 1 meter of the pile is going to be sticking out above the soil surface. Um, the total depth of the soil domain is going to be 8 meters. Um, there'll also be reinforcing. There will be Y25s, 12 Y25 longitudinal reinforcement placed within the concrete pile, while Y10 stirrups will be surrounding the longitudinal reinforcing. A cover of 50 millimeters will be used. Um, and yes, we'll load this pile horizontally and see the horizontal deformation. I will not run the model. I'll just set up the geometric part of it. But it should all be fine if you do run it and stuff. So yeah, let's get started. So we're gonna start off by opening FEMAP and we're gonna create a new file. I'm just going to save it. I'm going to save it as example1. And so what we want to do first is we first want to create new materials. So our first material is going to be C30 concrete. And we'll give that E value of, let's say, 40 times 10 to the 6 kilopascals. And then we'll give it a 30,000 compression strength, and then 0.2 poisons ratio. Then for our soil, we'll give it a Young's modulus of 100,000 kPa, a compression strength of 100 kPa, and a poisons ratio of 0.3. Our last one, we'll give it steel. We'll use a Young's modulus of 200,000 kPa. Let's use 50,000 kPa for the compression strength and a 0.3 for poisons ratio. These are obviously parameters that I've just put in. You can, obviously, depending on what you're doing, you can insert your own parameters and all that. So yes, once we have our materials, you can go here and you can just check and edit it and just see all the materials. So we have our concrete, soil, and steel. So now once that is done, we create our properties. So our property 1 is going to be the hexa 30. That's basically just the hexa concrete elements. So you select your material concrete and then the element type is solid. There we go, and you click OK. For the second one, we're gonna go hexa soil, and then you gotta select soil and then solid again. And you click OK. For 3, we're gonna use our longitudinal reinforcement of 25 millimeters. You select steel, and these are gonna be modeled as beam elements. Okay, that's right. So then the type of shape is going to be a circular bar, and since the radius is 25, the diameter is 25, therefore the radius is 0.125. Sorry, 0. No, that's right. Sorry, 0.0125. Sorry, I was just checking on my calculator. And then you got a draw section just to show how it will look. And you click OK. And you click OK again. And then for our stirrups, which will be 10 mils, again, they are modeled as beams. And our shape again is going to be a circular bar. And our radius is going to be 0.005. Again, you can draw a section just to see it all, and then you click OK, and OK again. So since that's done, so we have hexa 30, hexa soils, and then our longitudinal bars, and then our stirrup sizes. Okay, so now getting on to the geometric part. So what we're going to do is we're first going to model the pile first. So we're going to go geometry, we go solid to solid, and then we go primitives, we go new solid, negative, and then our radius of our pile, as we said, it's going to be 400 mils the diameter, so therefore the radius will be 0.2. The height is 6 meters. The reason why this is negative is because I've basically taken my origin as 0, 0, 0, and I've taken the height as 6, as it will be 6 meters within the soil domain. We will still put the 1 meter of concrete or of the pile above the soil, but we'll do that later. Then you click OK, and then there's our geometry for our pile. So in order to mesh this, we got to go mesh control, we go size on solid, we select it, click OK, and then we want hex meshing, and then for the element size we're going to use 0.1. This is basically the height of each element. You can choose it the way you want it to, but just be careful. If you make your element size too small, the computer might bomb out or it won't be able to handle it, so you just got to be careful of that. These default values, you can just keep it the same. That's fine, and then we click OK, and then as you can see on the geometry, yes, so all the nodes for the outer elements and all that is all there. Now in order to mesh it, we go mesh, geometry, hex mesh solids. We want hexa 30 because that is concrete, and then we click OK. And as you can see, we have our concrete pile that is 6 meters in depth and 400 millimeters in diameter. Okay, so now since that's that, we're going to do the soil. So now the soil is going to surround this pile. So we do the same thing. We go geometry, solid, primitives. We want a new solid, or you can actually add is fine. It's the same thing. Wait, let's actually just go new solid, negative. We're going to make the soil domain a radius of, let's say, 5 meters. The height is 6 as well, the length of the pile, and then we click OK. Now as you can see, there's our soil domain with our pile embedded within it. Okay, so now this is also a solid cylinder. Look, if I remove the concrete, you can see there's basically no hole, and we want a hole because we don't want our geometries basically to overlap. So in order to do this, we go geometry, solid, primitives, then we go to remove. Now we got to remove the radius of the pile, which is 0.2. So there we go. So now if you switch off the concrete, now there's a hole in the middle, and that's what we want. So now if you add it again, then it's there. Okay, so now what we're gonna do is we're gonna turn off I don't know why there's two. Oh, I think that was the previous one. Yeah, okay, that's fine. So now what we want to do is we're going to slice up this geometric, or the soil domain geometry. That's what we're going to do. We're going to put this in slices depending on where these nodes are. So you always got to make sure you have a center node in your pile. So in this case, yes, there is a center node. Sometimes you won't have a center node, and if this does happen, you just need to copy one of these, and then you got to move it to the center of this. We can do that if you want. I can show you quickly. So in order to do that, we go mesh, copy node, and we want to copy this repetition once, and we go methods, global axis. We want to copy it negative y-axis, and we're going to copy. I'm not going to use 0.2 because then it's going to put it right on there. So I'm going to use 0.15. Okay, now that node has been copied there. So I'm just going to change the color of this node. I'm going to make it bright yellow. So there it is. And then in order to do this, in order to move this node to the center, you go modify, move to node, and you select this node. And then it says, make sure it's on locate, and you literally go 0, 0, because remember our origin is at the top of this, and you click OK. Click OK again, and then our node is placed there. You can probably see it. Let me just zoom in a bit. It's just placed on top of it, so that is quite tough to see. I'm just going to backspace. So I'm just going to delete that node. Okay. So that's what you have to do if you do not have a center node. But in this case, since our mesh or our pile was meshed accordingly, we do have a center node. The reason why is we need the center node because we're going to be using this to cut. So what we're going to do is we're going to slice from there to there, there to there, there to there, there to there. We're basically going to have slices of our soil domain. Okay, so in order to do that, we are going to go geometry, and we go solid, and we go slice. Now this wants us to select what geometry or what number do you want to slice. So remember, if you look here, it says our soil domain has a geometry ID of 2. So we want to slice number 2. So as you can see, the ID is 2. And then we'd go by nodes. And now we want to select this node, that node, and you got to make sure you get that node. You click OK. And as you can see, it has sliced the two solids in half like that, along the plane where the origin and that. Okay, so you can then, once that is established, you can delete that geometry if you want to. So now we're going to do the same thing, but we're going to slice this accordingly. So what we're going to do, we're going to go again, geometry, solid, slice, make sure it's number 3, we click OK. And now the node, it's that one, the middle node, and that one. You click OK, and there you can see it has sliced it again. So there's our slice. So that's number 3. Geometry labeled ID number 3. So now we're going to do the same thing with this one. So we're going to go, okay, geometry, solid, slice, number 4, because 4 was that geometry there. And now we're going to select this node, your center node, and that node. Boom, done. Okay, so now you can see we have 1, 2 slices, so we have one more slice to do. Okay, so as you can see, this part is number 5. Okay, I just want to make sure I can reach those nodes. Okay, so again, we go geometry, slice, number 5. We select that node, and that node. And there we go. So as you can see, there are slices according to those nodes. So I can delete this number 6, and there we go. So now, once that is established, what we're going to do is we're going to mesh each one of these slices, and then once that is meshed, we're going to copy it over to the left, and then we're going to copy the whole thing down to the bottom. So in order to do that, we're just going to turn off the concrete. So basically, as you can see, there are our slices. That is the soil. So what we want to do is we want to turn that off. Okay, now in order to mesh this, we have to go mesh, we go mesh control, we go size along curve, and now we got to select basically this, and this, so the top ones. We click OK, so the number of elements we want along that path, I'm going to give it 15. And now since you want your smaller elements closer to the face of the pile, we don't want equal length. We want the smaller elements closer to the pile, if that makes sense. So what we do then is we click length and we go the geometric bias. So basically your smaller elements will be closer to the one side than the other, if that makes sense. So we have 15 elements, but the elements closer to the pile, they're going to be smaller, and then they're going to get bigger towards the outer diameter of the soil. So therefore, we're going to use a bias factor of 6. If you use a bias factor of 1, there's no difference. Then the elements will be equal. And then we want small elements to start, which means they're going to start at the pile face. Then you click OK, and as you can see, there is your elements. Your elements are going to form like that, where they're smaller, closer to where the pile is. Okay, and then we just do the same for the bottom. So then we go mesh control, size along curve, 1, 2, 3, 4. We do the same thing. We want 15 elements, length. We go 6, and then we go small elements at the end. See, and as you can see, you can see where the elements will form. So since that's done, then we want to put a singular element on the outside, so there, and then we want that curve and that curve. So then we do again for the top, so we want that curve, that one, and that one. So now we only want one element within that slice, so therefore we use 1 and we keep it equal. There we go, and we click OK. Now for the last one, it's the same thing, but now we're going to do the vertical. We're going to basically separate this thing into, because remember we said our hexa element size were 0.1 meters, so therefore, and this depth here of the pile is 6 meters, therefore we need 60 elements, because you go 6 divided by 0.1 will give you 60. So therefore we need to select all 4 of those, and then the inner here, and then we use 60 equal because we do not want a geometric bias. And there we go. Now you can see that the elements are here. Just want to make sure of something. Sometimes okay, that's fine. So as you can see here, it has basically broken up this into 60 elements. Each one of these highlighted red dots are basically your nodes. Yeah, so you basically have to select every single curve or every single size and assign what elements, what size you want to do. So now in order to mesh this, you go mesh, geometry, hexamesh solids, you select both of them, and this is our soil, and you click OK. And there it is meshed. Now you can see that it has created our elements where the small elements are closer to the pile, and then there are elements on the bottom as well. We will delete the geometry just now, so we won't need the geometry later. Okay, so now I just need to do the remaining other slice. Let's just turn off the soil. So now this is just exactly the same thing. I just broke it up a bit. I'm just going to do it quickly. Make sure that's there. 15, 6 bottom. Okay, now I want that one, that curve, and that one. So we want equal spacing and one element, and then we want all the vertical ones, and that is 60 then. See, so as you can see, it has done it all. I recommend you do, like, make sure you do each slice accordingly, like just check every single one like this. Just make sure you can see all the nodes and it's all lined up, and just do that. So now I just need to, which one is it? Okay, so I'm gonna mesh the remaining slice. So we go mesh, geometry, hexagon solids, soil, switch it on, and there we go, it's done. So now you can see we have our soil and our pile. So now I want to delete the geometry of the entire thing because we don't need the geometry anymore because we have our elements. So we go geometry, and we go all, and we click yes. So there we go. There we have our pile and our soil domain. So if you turn off the concrete, then there's our soil. So I'm just going to quickly change the color of this so we can see it better. Let's make it that, and then just switch it off, and then I'm just going to change the color of our concrete. Let's make it gray, and then you can see the concrete. So if you turn on your soil, there we go. So now what we want to do is we want to reflect the soil over the y-axis. So in order to do this, we just turn off the concrete quickly, and we go mesh, reflect element, and then we select all of them. We click OK. Click OK again. Make sure it's on nodes. So we want that node, just make sure it's selected that node, and then we want this node. Okay, you just got to make sure you've selected all the nodes, and then we click OK. And then there we go, it's reflected about that axis then. And as you can see, that is all done. So now what I want to do is I want to reflect all these soil elements over the x-axis. So we do the same thing, reflect element box, select all of them. Okay. So we want that node, and just make sure, and that node. Click OK. And as you can see, there's our soil domain. And if you add the pile's also there. Okay, so now what we want to do is we want to copy, because remember the depth of this soil is 6 meters, and we said initially we want it to be 8 meters. So in order to do this, we have to go mesh, copy element, and then we select the bottom elements. Oh yeah, one more thing, just make sure your concrete's turned off, so it doesn't copy that. And then we go element box, and then just select the bottom row of elements, which is that one. We want to copy it 20 times because each element is 0.1, and we want 2 meters below to get 8 meters in total. So negative Z, and we're going to copy it 0.1, which is the element size. And there we go, there's our soil domain. As you can see, there we go. So now in order, because remember here there is a gap because there's a hole right through, so we basically need that also to be a soil. So what we're going to do is we're just going to turn off the soil, put on the concrete, and then in order to do this, we're going to mesh, copy element. We're just going to select this whole row of elements. We're going to copy it once, negative Z, 0.1 because the element size 0.1, and then we're going to go just change the color to soil. It was this one, and then we want to copy this 19 times down because remember we've copied one element, and we need another 19 to make up basically the 8 meters in total. So we go 0.1, and as you can see there's the soil, but remember this is still modified, or this is still classified as concrete. So in order to do that, you go modify, update elements based on property ID, you select all the Braun elements, click OK, and we want hexa soils. So that's done. I'm just going to coincide nodes to just make sure you can see it. So there we go. So if you put on the soil, it's there, and then there's the concrete. Just remember we also wanted to increase this by a meter. Let me just show you, because in case, see, so that is flush now with the soil. So in order to, because we wanted a meter sticking out above the soil surface, so in order to do that we wanted 10 repetitions because it's a meter and each element is 0.1, So positive Z and then the length 0.1. So there we go. Now it's sticking out by a meter. And then there's our soil. So yes, that's basically the soil and the pile done. We're going to move to the reinforcing now. So in order to do that, we don't need the soil. We're just going to zoom in. And basically what we said is we're going to install 12 wide 25s in a circle with a 50 millimeter cover. So in order to do that, I've created a spreadsheet on my own, which is this. I've just created, it's basically the coordinates. So I've got a diameter of the pile, I've got cover, I've got the diameter of the reinforcing, so that's 25 mils. I've got the diameter of the stirrups. And then, yeah, I've just calculated basically the positioning of each, with the degrees, each coordinate for each reinforcing bar. So if you look at 0 degrees, I have a y longitudinal of 0.15 and then an x of 0, which makes sense. Then at 90 degrees, we have a y of 0 and then x is 0.15. If that makes sense. So then what we're going to do is we're going to, a quicker way to do it is we go mesh, copy node. So we want to move, we select the surface node, just make sure it's selected it. We click OK, repeat once, and then we're going to go positive Y, and remember our length is 0.15. We click OK, and then as you can see, the node is there. So I'm just going to recolor it. What is that? Yo, that node's just very, very small. It's not easy to see. Okay, that's fine. Color node. Okay, there it is. I see it. So you just got to make sure you've selected it. Then we go yellow. We want it thick. And there's our node. Okay, so sorry, it's just struggling with the connection a bit. Then we want to do the same thing. So if you work it out within 360 degrees, if you put 12 reinforcing bars, you're going to have a reinforcing bar at 0, 30, 60, 90, 120 onwards to 360. So now we want we basically want another node at 30. And then another node at 60. So this is the X. Sorry, this is the Y. And this is the X. These are the coordinates of the longitudinal reinforcing. So I'm just going to copy paste that. So again, you go mesh, copy, node. You can take that one. Another way you can do it, you can do it the same way. So you copy that center node and you just plug in these coordinates. Another way you can do it is you can take this difference. So this minus this. And then I'll just use the exact number. And then you do the same for the X, which is just 0.075. So I'm just going to copy this. And we go mesh, copy, node. Now since we did it the difference, it has to move negative y, and we paste it. Now you can see it's moved that node down. And then we want to also move the node positive x. I think the value was 0.075. And there we go. Now it has moved it to basically, now that is 30 degrees. And then we do the same thing for this one. So we take that y minus that y, and then we got to take this x minus that x. Okay, so these work out the same. Okay, yes, that does make sense because it's from the previous node. Yes. Okay, so we're going to mesh, copy node, take this node, just make sure to select the right one. We repeat once, negative y, and we paste that. See it, so it's moved that node. Then we go, because remember x and y is the same thing, so then we take that node, we move it. No, sorry, that was the wrong command. Modify, move by node. Okay, it's selected at positive x. And click OK. So there we go. That's then 30, 60 degrees. Then to do 90, your y is going to be 0. Sorry, I'm just checking. Yeah, so you're going to be moving your y node 0.7 down, and then your x node will be that difference. Okay, so let's do that quickly. Mesh, copy node, take that node. We go negative y, and this was 0.075. Click OK. Yes, it makes sense because it's on that line. And then we go move by node. Okay, select the right one, positive x, and you paste that. So now, as you can see, we have our nodes on this. Okay, so in order to get the reinforcing bar, what we're going to do is we're just going to copy these nodes. Repetition 1, and we want gonna go negative z. Now we're gonna make each bar 0.2 because it needs to lie at the interface. You can make it 0.1, but I'm gonna make it 0.2 because it needs to cross over a boundary. Okay, so that's done. So as you can see, now we have those elements. So now to model the reinforcing, you go model, we go element, and we want if the y25s, remember it's a beam element, and then we want from this node to that node, and then okay, just got to make sure the orientation, so this is going into the page, so I'm guessing it's positive x, and there we go. That has done it. I'll switch the view now. I'm just doing all of them. I'm just going to put the cross section on. To do this, you go element, orientation, shape. Go show cross section. Yeah, here we go. Okay, so there are our reinforcing bars, basically. Okay, so now we want to copy these elements over to the left. So, okay, that's fine. The only thing is for this, we need a center node. So what I'm going to do, I'm just going to mesh, copy node once negative y, and I think it was 0.075. Yeah, was it? Okay, let me just check if it's in the middle. Okay, no, it's not 0.075. It was 1.5, that's what it was. So mesh, copy node once negative, so 0.15. Okay, so now that node should be in the middle. Okay, so now we want to do again. So we go mesh, reflect, we go element. So we want to select all of these, click OK, OK, and then the nodes are then 1, 2, 3. And there we go. So now it's reflected basically over that. Okay, yeah, that looks right. So now we do the same thing. We want to reflect it over the x-axis then. So then we do the same thing. Now we select the nodes. So we go 1, 2. You can do it over that one. That's fine. Okay, so that's done then. Okay, so remember, each of these elements are 0.2 meters, and our total length of our pile is 6 meters. Therefore, if you work it out, you're going to have to copy all these elements 34 times because you already have these elements. So we go copy, we go 34, negative z, and it's 0.2 because each element size is 0.2. So there we go, it has copied it. I'm just going to change the color of these elements. Oh, your circle. Let's change it to blue. I'm just going to change the background. I think black is 0. Okay, no, black is, so I think white's 124. Yeah. Okay, so as you can see, they're blue now. Okay, so that's then the reinforced. Oh, okay, let me just show you. Just make sure then, that it is flush with the pile. That you did copy the right amount. So I'm just gonna put on the wireframe. Yeah, see, so there's the pile and it comes right to the end. You can put solid frame on and just check. So concrete off and on. See, so as you can see, it's all right. So now with the stirrups, the same thing applies. Let me just delete all this. So I've made another column for X and Y stirrups. So as you can see, the first coordinate for the Y stirrup is 0.165, and that is from the origin. So what we're going to have to do, we're going to go mesh, copy node, select this once, it's positive Y, and that's 0.165. Sorry, I just wanted to just label the coordinate system 0. Okay, doesn't like that. Okay, there we go. So I just wanted the coordinate system in black. Okay, so that's basically the coordinate of the first stirrup. So now it's very important to take note of this. We're going to be modeling the stirrups as beam elements, straight lines. You know, you can't, it hasn't been developed yet where you can use curved beams. It has to be then a line. So we're going to model a line from there to there, there to there, there to there, and then we're going to reflect all of it. But you got to make sure that the node is on that line. In order to do this, you just got to play around. So here I've got 28.5 degrees. So you can see the X and Y stirrup coordinates are there. Okay, so I'm going to take, this is the Y coordinate. So we just turn the concrete off. So there's a node, mesh, copy, node. Take this node, positive Y, and a length of so much. See, so you can see the node is there. Then we take this, modify, move by node. It was that node, positive X. Okay, so now if I turn on the concrete, you can see it's quite close to being on that line. But we want it very, very close. In order to do this, you literally have to go and physically measure it. So what I did is I went tools, you go distance, you allocate, so you go from there. Sorry, I don't know what it wants. Okay, we want between. That's what we're going to use, not locate. So we're going to go from there to about there. And then what you can see the X coordinate is of the one is that and that. So what you got to do is you got to take your calculator and you got to minus this from that. So 0.07992609 minus 0.07836445. Okay, so that's 0.0, yes, the value is that. Then we're going to move this node, negative X, by that amount you just calculated the difference. And I got 15616.4. And you can see it's moved it. Sorry, I did miss out a decimal because I did that on my phone. But you can see then you got to move it even closer. So then you do exact same thing. You measure there and then you move this node to there. Okay, so once that's done, you're going to have to do it for, sorry, I'm just zooming out. Once that's done, you're gonna have to do it for all the other nodes. So again, we're gonna copy this. Let me do it quickly. So this was like at degree 57. In order to get these 28.5 and 57, I literally took my protractor and I placed it on my screen and I got basically that angle. But I'm just gonna get the other node, so we're just gonna remove the concrete. So it's at about 57 degrees. So to do this, we go mesh, copy node. Hey man, sorry. Mesh. And that was the Y coordinate, so positive Y, a length of so much. There we go, and then positive x, we go modify, move by node, we move that, positive x. So there we go. So now that has done that. So if I put the concrete back on, you can see it's almost on that line. But again, you have to zoom in, and you can move then this thing horizontally. So you do the same thing, you go tools, sorry, that was angles, tools, this distance between there and there. Now we look at the y coordinates. Now you got to minus that from that, and then you go modify, move by node, and you move it by that difference that you just calculated. So yes, once that's done, then we just do the last one. So the last one is the same coordinate as that, so 0.1675. So we just turn that off, and we go mesh, copy node. So this was positive x, 0.1675. Okay, so now that should be done. Again, this should be on the line because this is exactly perpendicular. So if I do zoom in, you can see it's exactly on the line. And we want it on the line. That is just the purpose of Recon and how it analyzes the beam elements and stuff. So yes, once that's done is we can turn off the hexa, and we can model the stirrups. So we go again, model element, and we go F10. So we want to go from that node to that node, then from that node to that node, then from that node to that node. Let me just turn that off. And then I'm just going to change the color quickly. Okay, let's make it orange. Okay, so now we want to copy the elements. We want to reflect it, basically, the same as we did with the longitudinal. So I'm just going to put that back on. So then we go mesh, reflect element 1, 2, 3. Click OK, OK, and then it's just very sensitive. Okay, the nodes we want are then this one, the very top node. Okay, it's selected it, you can see there. And then the bottom node, which is that one. You can see that's the very bottom node. You click OK. See, so as you can see, it's basically copied that like that. And then we do the same thing. So we go reflect it. We select the elements that we want to reflect. Copy. Okay, so for that, we want this node, and this node. And there we go. So there are our stirrups here. Okay, so now what I'm going to do, I'm just going to turn off the bars. So modify, I'm going to move this by, because remember each element is 0.1. So I want to move this by 0.05, so it sits in the middle of the element. And now since there are 60 elements, therefore, remember we said we're going to put it at 100 mil spacing, so that means we're going to have to copy this 59 times. So copy, repeat 59, negative Z, and the spacing will be 0.1. So there we go, it is copied all that. I can put on the bars. Oops. Okay, we made a mistake. Okay, let me just check. "60 elements." That sounds about right. I think, did I type in 49? Okay, wait, let me just want to make sure of this. Okay, look, so I just need to move this again because I removed that. Negative Z, 0.05. Okay, so I've moved that down now. You can see if I put on the wireframe, it's sitting in the middle there. Okay, so now I want to copy this. Repeat 59. That's 0.1. Oh, sorry. It's because, sorry, the pile is 7 meters. So it's actually, you got to copy it 69 times. Sorry, that is my fault. Sorry, apologies. Just turn off the concrete, copy element, box. So 69, Z, negative 0.1. Okay, that should be fine now. So if I put on the concrete, you can see each stirrup lies embedded within each hexa. And then just to confirm, if you go to the bottom here, there we go. So everything's lined up. If you put the solid view on, just remove the concrete, put the bars back on. So there's our cage basically. And there we go. You won't be able to see the stirrups now. Yeah, so that's right. Just one more thing, just make sure then you delete this node, because that was just a point we used. So now that node's gone. And yes, then that is done. So it's your stirrups done, everything else, it looks all good. So now I'm sure from now on, you just got to add boundary conditions and add loads and then renumber and coincide elements and nodes. So I can do that quickly. So we have to go model, constraint, create a new one. We'll just call it fixed for now. Okay, then we go model, then we're going to create another load. We're going to call this load. So now we've basically just created the load and constraint group. So now for the constraint, we're going to put nodal. So we're going to use a polygon, and what we're going to do is we're basically just going to, sorry, let me go this way. So I'm just selecting basically all the outer nodes. Just got to make sure you don't touch any of the other nodes. You click OK, and we're going to put restraint in the Y and X because we still want to allow this thing to deform the Z. So there we go, the constraints have been added. And now we just gonna turn it off. I just want to then add constraint to the bottom. Okay, and we're gonna restrain it in the X, Y, and Z. So we're not gonna allow deformation in all directions. So that's basically fixed. This is just to overwrite it because you have already assigned constraints to the outer nodes. And now for the load, we're going to assign, let's say we're going to assign a load 0.5 meters to the nodes above the soil surface. So to do that, you just got to make sure all your everything's switched off. Okay, we want the concrete still. You can actually leave the soil. I want concrete. There we go. Okay, so I don't want the steel because if you leave the steel on and you select those nodes, it might assign a load to that node of the steel. So if you switch on your steel, there will be nodes in here, and then if you select it, it might assign a node or a load to that node. So how we do this, then we go model, load, nodal, pick the box. So we're gonna select these group of nodes because that's 1, 2, 3, 4, 5. It's basically 0.5 meters now above the soil. So we select them, and then we're going to assign a 1 kilonewton load in the X direction. So that's what we've done. Now to see how many nodes or nodes we have, we just go check and you go sum forces. Just click OK and OK. So you can see there's 54 nodes. Okay, so if you want to apply a 500 kilonewton load to this, you're going to have to take 500, divide by 54. Let me just get this out quickly. So you go 500, divide by 54, and you got to select all this. And you go modify, update other, scale load, select all, and we multiply by that much. So now you can see it's multiplied basically every 1 kilonewton load by that factor. So just to check that it's all right, sum of forces, and then you can see there's 500 kilonewtons. So once you've established the node, you just got to choose what analysis you want. So we go model, and then we go non-linear analysis. Sorry, we choose static, the number of increments. So this is the load increments. So if you use 10, it's going to go up in 50, 100, 150 increments. Number of iteration steps, you can use 25. The work done in order to complete the Newton-Raphson method, or in order for it to converge. Once it's reached that, it will stop. Then the number of iterations before update, you can use 5. Output control, no, we don't want that. So then that's done. So then when that's completed, you can just select all the stuff. I'm just checking everything, so everything's right, everything looks alright. Then you just got to check coincide nodes, merge all of them. You can see a whole bunch of nodes have been merged. You can check elements, coincide elements. You do a full check. You can see quite a few elements have merged. I can also just change all the node colors because all of them are a bit different. So you can select black, make it that's fine. So it's quite small. Okay, so now all the nodes are, if you want to put the constraints on, all the constraints are there. If you want to take away stuff, you can take away the load, the constraints, you can even take the nodes away. And then don't forget, before you run it, you have to renumber all the nodes, which I'm doing now. And then the same with the elements. And then that's done. Another very important thing is you need to just make sure that your smart properties are you've changed them and have modified them, else it will not run. So I'm just looking for my folder. So the smart properties, remember that's here. In order to do that, you just got to select. These are hexes, so they're hexa property. You can save this as 3. Just remember to click apply. The same with the soil. It's hexa properties. Sorry, this is 3. Sorry, the concrete is reinforced, so you can put that as 1. Yeah, don't forget to click apply quite a few times. And then these are beam properties. So yeah, I'll make sure of that. So rectangular steel, we can just choose that. 200. Sorry, I'm just doing it for you now. Poisons ratio, choose 0.3, that's fine. No steel hardening. Oh yeah, I'd want you to use 0.3. Okay, there we go. We don't want steel hardening. You can select there if you want. I'll make that 500 MPa. Okay, and then you click apply. For the wide tend, you can do the same thing. I think actually I use you have to use the reinforcement property, since it is in concrete. So that's fine. I just want to make sure of this. That's fine. That's fine. So okay, sorry. So you got to make this reinforcement property, and then you fill up all this. Make sure this is 10 and whatnot. And there we go. Then you, once this is all done, you got to do the same for your stirrups. Choose reinforcement property. Add all these things in. Make sure that's 1. That's 0.2. Pre-stress, no. And then don't forget to click apply the whole time. And then once that, you just click save, and then you're exported FEMAP neutral. So you just save it as then example 1. You choose the 9 version 9, and there we go. Then that's saved, and then yes, you'll have to just copy this and then copy and paste into Reconin, and then that is done. So that's basically it. That's constraints, loads, renumbering, merging, coinciding with steel, and your concrete pile. And yes, you can have a closer look. Let me just close this, turn this off. There we go. Yeah, it's quite cool. And then you just go. Okay, so that's how modeling a singular pile with embedded in soil with specific dimensions. Obviously, if you use different dimensions, things might change, especially when you use a different diameter pile, because when you when you do that, basically your elements here, they will be different. So you might have more slices, or this might not be perfectly 90 degrees, but it all follows the exact same process. Even if you have different reinforcing sizes and stirrups and cover and all that, that can all be adjusted. Again, it is good to then create just an Excel spreadsheet with those coordinates, because it does make it quite easier. So yes, I hope that was helpful, and yes, if you have any questions, feel free to please email me and I'll get back to you. Cool, thank you, and enjoy your day.